So I decided to continue the topic about networking, and today I'm going to talk about about OSI model, Open Standard International, Open Standard International, Open Standard inter something model. This model. We learned about this model in the university on our networking classes, and it consists of 7 levels. And usually the study of this model starts with the lowest level, the first level, which is the physical level, like the wires, the physical wires that connects to computers, or in case of the whole network, like local network. I don't remember, local network or internet in general. There are not only wires but different switches, hubs, routers that connect different wires or different types of networks to other types of networks, or for example I don't know, maybe hub connects the wires from the local network to the outer network, and there are some transatlantic cables that goes along the bottom, on the bottom of the sea. I think they're huge in diameter, and they have a strong shell to protect it from let's say the shark. And then these huge cables had to connect to some devices, and then smaller cables, smaller wires go out of these devices on the other side, and then they connect to local for devices. They connect to devices local for the homes, for the buildings, and at some point you connect your modem to the socket that is set outside of your flat, yeah. And this point outside of your flat is where the network that belongs to the government, to the national telephone company. At this point, this cable connects to the cable that belongs to you, to your home network. So all this stuff is about the first level of OSI model, about the physical level. And usually in all the textbooks about this stuff, in Tannenbaum's books on networking, the description of OSI model goes from the first level and up to the 7th level, and usually I stopped somewhere at the 4th level, and then it was difficult for me to imagine, to understand the 5th and the 6th level, and I never reached the 7th level. But there is another book, I don't remember the authors, maybe Kuros, where they took the approach of describing OSI model from the top to the bottom, from the 7th layer, and in this case the 7th layer is what you see on your computer in your operation system, like browser. The browser is an application that works on the 7th layer of OSI model. Actually, all the applications in the operating system works on the 7th level, and then okay, as I said, I can't really understand the 5th and the 7th in the 6th levels, because they are kind of too abstract, and they can be easily combined with the highest level into this one application level, where a browser or works, or where you start your console window and then type ping, for example, Google.com, and this ping application works on the 7th layer, but all the other stuff goes under this level. And okay, there is another model for the networking, and it has only 4 levels, and it's easier to understand because this model combines several levels into one level, because these several levels are too abstract. They have no real representation in the applications or something where you can kind of touch it with your hands. So in this 4 levels model, which is called usually TCP IP model, there are 4 levels, and the first level is the physical level as well. Next goes the IP level, then TCP level, and the 4th level is the application level. And this model is more intuitive, because out of all 7 levels of OCI model, I remember and understand without looking at the book only these 4 levels, like they are 1st, 3rd, 4th, and the 7th layer of the OSI model. So the other levels are not so important, they are just some abstractions. So we'll talk next about this TCP IP model, and the first level, which is the physical level, remains the same. It's about cables, wires, all these physical circuits, modems, hubs, switches, and routers, and of course computers themselves. And the next level is IP level, which is the level of abstraction, but we're all familiar with it because we talk about IP level when we talk about IP address, something that consists of four numbers, like 192 dot I don't know, 100.60.24, something like that. And one of the most famous IP addresses are localhost, which is 127.0.0.1, but usually the people who have some experience in computing are familiar with this localhost address, and maybe the most famous address is 8.8.8.8.8. So 4 numbers which are all eights. And this is the DNS, the IP address of the Google DNS server. So when you have some troubles with your browsers, for example, and the browser shows you that it can't open some website or other stuff, the first step you should do is to ping this Google's DNS 8.8.8.8 because at some point or sometimes you have DNS problems, and that's because these DNS servers are down for the moment, so your computer can't resolve some internet addresses that you use to reach the sites, and that's why all stops working. So usually you can't affect this type of problem. You can solve this type of problem anyway, by any means. You just wait until the internet service provider somewhere resolves this problem with the DNS servers, and then everything goes well again. So IP addresses are used to identify any computer or any server in the space of the internet, and the internet is the whole world connecting the whole world of different computers, servers, which are interconnected to each other, and it's like the one huge shared space or room, and to find the necessary computer, it's like a big city, and to get to some building that you need, you have to know the specific address of this building, and you have to know the map for this particular city. So the role of the maps usually plays the role of the maps is played by the routers, so they are not of your concern. They are the concern of internet service providers and other organizations. So you just need to know the address, and in this case IP address is the analog for the real address of the building in the city. And the way these addresses are assigned, this way is determined by the government organizations as well, and they're not of your concern, and you can't somehow, influence them or change these addresses, but you can learn the rules and play according to the rules, and use the available addresses, or learn some addresses and like visit these addresses. Yeah. So IP address is the set of numbers, and the usual address that we use, like google.com or I don't know, Rambler, Yandex.com, they are just human readable representations of these addresses, because it's easier to remember the name Google or the name Yandex than to remember for 3-digit numbers that are separated by dots. And of course there is some database which is used to translate this human readable internet address into the numbered IP address. This database is called DNS servers, domain name servers, and their only purpose is to receive the human representation of the address and then find the numbered address in the tables that they keep in the databases. And when, so let's go back to the browser. When the user types maybe types, or when user, let's say user knows the site like yandex.ru, and he types this site into the browser and clicks enter, and the first step that browser takes is to get this internet address and divide it, check it for being valid. Usually the first part of this address is HTTPS, which is the name of the protocol, and protocol is the thing that works. I'll go back to the protocols. So I'll come back to protocols later. HTTP is an application level protocol. So this is the protocol that works on the highest level of this TCP IP model. And usually you don't need to type this because each browser kind of adds this prefix by default. Then colon to slashes, and the domain name of the server, yandex.ru, for example. Of course, you can type something like yandex.ru/something, which is the additional information that identifies the particular HTML page that you request on this particular server. But we'll take the simplest example. So the browser gets this domain name, which is google.com, and because this name is in the form of a human readable string, the browser sends this string to the local DNS server that was set into the browser's settings. So the browser knows which DNS server to use to resolve this name. And when this local DNS server receives this string, it looks looks up for it in its database, then it gets the DNS server gets the corresponding IP address in the form of numbers and sends it back to the browser. Then browser knows what IP address to address during the request, and the browser sends the request for this particular address to the port 40 in the case of HTTP protocol, or 443, no, 80, okay, 80 for the HTTP protocol, and 443 for the HTTPS protocol, and these ports are default, so you don't need to add them to the string of your that you type in your address bar. And when the request reaches the particular server with the resolved IP address and goes into the port of particular number, then the server creates the responding HTML page and creates the resulting the HTML page, requested HTML page, and then responds back to your browser with this page, and you see that your browser shows you this HTML, this page with something on it, which is default to the search engine that you use, like Yandex.ru or Google.com. So the interesting part of all this process is that even if you just typed only the string and then you see the result on your screen, there were two basic steps in what happened behind, under the hood of your computer, of your operation system, under the hood of your browser. Yes, first it was the request to the DNS server for this particular string, and then the request to the server itself to get the necessary page. Yeah, and it's quite a complicated example, but it uses this IP, the second level IP of IP addresses, about which I started to talk according to this TCP IP model. And the third level is TCP level. It's the transport layer, and TCP is the most famous transport layer that is used that is used to send the information from your browser to the server and to receive this information back. And TCP is the default protocol that goes with HTTPS application protocol. Actually, HTTPS protocol does not exist. HTTPS is a convenient name for the combination of TCP plus, I think, TCL maybe, transport secure level, which encodes the information that you send, and at your computer then decodes it on the server, and vice versa. And this combination of TCL plus TCP was named HTTPS, which is analogous to the default HTTP protocol. So actually you can't see TCP level very easily, because there is no utilities which are default for the Windows operation system to show you this TCP something, and there is no need in looking at this TCP protocol, because it's really a transport media, transport means to send the information. It's not about IP addresses for the particular computers in the internet. It's not about the application that you can use. This is this intermediate step, and usually it works quite fine, and the main responsibility for this TCP level lies on the shoulders of internet service providers or government organizations. So the application programmer, or moreover the application user, can't change or can't do anything to this TCP level. So basically you need only to know that there are two types of transport layer protocols, which are TCP and UDP. And UDP is the most simple one. It just sends the information, let's say, from the server to the computer, to your browser. And it is usually used for streaming some videos or something that is not so important to be kept in its entirety, in its whole. Like, when you watch some video online and you have some pixels because some frames of your video were, I don't know, jammed, ruined. It was just a second when you noticed it, and then you watch the next video frames, which are quite alright. And it was the effect when this UDP protocol failed to deliver some certain frames, but because you continue to watch, you don't stop to let's say enjoy some particular frame during your watching. It's not very important for you to have all the frames of the video in the perfect state. But when you get the picture, for example, let's say you have your pictures from your smartphone, and then you upload them to the Google server, and you keep them at your account, yeah. And then you want to download these pictures and print them into the, I don't know, photo photo paper or something to have this in the actual picture form on your desk. Then it's important and crucial for you to upload all the information in your digital picture from your smartphone, and then to get all the information in your picture from the Google server. You won't be satisfied if some of the pixels, some places on this picture will be lost, if some places are lost, and if you just get some I don't know, black dots instead of these lost pixels. Yeah, and to prevent this loss of information, TCP protocol is used, which is the reliable protocol. It establishes the connection between the server and the browser, and when this connection is secured, well established, then only then the TCP protocol sends the information to the server and or receives the information from the Google server to your computer, and it guarantees that the information is never lost, because it guarantees that what you sends the server gets, and vice versa. How it was achieved programmatically, it's not our concern, because as I said before, TCP protocol is the responsibility of internet server providers and government organizations, and they have the means to make this happen. So the fourth level of this TCP/IP model is the highest, is the application level, where, as I said in the beginning, all the programs that communicate with internet lives. The browser, Zoom, ICQ, Telegram, Skype, and other stuff, even ping utility, and ping utility and tracer utility that have the command line type of interface, but you start them in the application level, and then they perform the operations through all the levels, through the TCP, IP, and physical level. Then the data goes over the wire to the server that you want to reach, and then the information go upward from the physical level through IP, TCP, and to the application level at the server computer. Then the computer resolves your request, and the process starts again, repeats again. And to finish the topic on this model, networking model, I need to mention that there are that all the information that is sent through the wires is represented just with zeros and ones, which that are called bits, and the bit is just a signal of some level. So somewhere the micro element can set the current of one level and the other level. And when these two levels are distinguishable, we can say that the lowest level is 0 and the highest level is 1. So changing these levels, the electronic devices can create these abstract zeros and ones, and 8 digits in a row create a byte, which is the minimal representation of information in computer. And then these bytes combines into huge sequences, and computers interpret these sequences as the necessary information. So when you type, let's say you request solar system in your browser, then your browser takes this particular string, represents it as the sequence of bytes, and because your interaction happens on the application level, then this string is sent to the lower level, which is TCP level, and at this level some headers and footers, I don't know, some additional information is added to the beginning and to the end of this string. And when this information sends to the IP level, additional header is added to the beginning of this whole information, and all this big data that consists of the IP header, TCP header, and your string solar system is sent as the representation of bytes, and physically as the different levels of the I don't know, current over the network on the wires. All this information sends through the wire to the server targeting computer, and at that server all the information again interpreted from the electrical signals into the bytes, then at IP level IP header removed from this information, then at TCP level TCP header removed, and then at application level the server receives your string solar system that you typed in your browser. Of course, this process a little bit more complicated, because the information is not sent as the whole string with the headers that were added at each level, but the information itself is divided into the packages of some particular length, and then each packet encapsulated in these headers at each level till this small packet is sent over the network, and on the server all these packets are collected together, they are put in the right sequence, all the headers removed from these packets, and then these packets are combined into the initial string, which was the solar system. So it's kind of difficult to explain without any pictures, and it's difficult to understand from the single lecture, because this networking thing has lots of sides, and like the sun is the sun, but you can characterize it by the heat from the sun, by the color of the sun, by the form of the sun, or even by the helium that goes through some thermo something reaction in the core of the sun and creates all these characteristics. So you can't just to describe the sun, you need to describe each of these characteristics and then combine them together and make the summary of what the sun is. The same way, to describe the networking, you need to understand each of these sides, like TCP model, the work of the browser, dividing the message into packets, and lots of other stuff. And when you understand some individual characteristics, you can put all this together and get the whole picture of what networking is. So for the next lectures, several lectures, I think I will continue to describe different parts, different characteristics of this networking process, and maybe somewhere later I summarize all this and combine all this into one whole picture. So it's already more than 40 minutes of my talking today. So that's all for today.